Good morning, everybody. Welcome to the webinar on Comet NEOWISE. I am Jayant Ganguly from Regional Science Center and Planetarium Calicut, and with me we have Sri Manas Bachu, who is the curator and project coordinator of Regional Science Center and Planetarium Calicut. So, welcome, sir.
Thank you very much, and good morning to all the viewers. This new comet is a new visitor to our sky, and so we thought that we must present it to the people, and we must tell the story of the comet because it will be of general curiosity. But beyond the curiosity, there are a lot of issues that we both will discuss and present so that you can understand what really is to study about a comet.
Yeah, so actually after a long time we are witnessing a bright comet. Last time actually it was Hale-Bopp, and we from Calicut did a very wonderful observation. A lot of people actually enjoyed the comet, and this suddenly it came up from nowhere. Actually means we didn't have any hint. Normally amateurs take a telescope and discover the comet as such by hunting from one day to another, and suddenly they discover a comet, and then it gets announced. But today we see that it is discovered by a spacecraft and by data analysis. We will speak about it sometimes. So as we move on, actually this comet, how do you feel? What is meant by comet?
Yes, what you said is interesting, and it happens really because our solar system, as it appears in a common rudimentary book, is not the full picture of it. Normally we are aware of the central sun and then the planets rotating around it, but that's not the full story. When it formed, when the solar system formed from the planetary nebula, there was differential ambience over a very large span of the space, and accordingly different sort of materials generated in different parts of the planetary nebula, and it is now understood that towards the close proximity of the sun, the materials that generated in the inner solar system, they were more rocky in nature, and they lacked, since the temperature was quite high there, the materials could not contain ice, but those materials which accumulated, those planetesimals which accumulated out of the dust and other compounds present at the outer part of the nebula, there they contained quite a large amount of ice, and when finally the solar system formed and came to its present shape, it is seen that two very interesting constructs have formed around the solar system. Just beyond the orbit of Neptune, there is one coplanar structure of planetesimals rotating around the solar system in the same direction as the planets are rotating. They are called prograde motions, and they are huge collection of icy planetoids, I would say, or you can call them meteoroids also, but meteoroids are a little different from the point of view of terminology. When they come inside the solar system, we call them meteoroids, but when they are residing in this construct outside the planetary system, they are called, it is collectively called the Kuiper belt. And beyond the Kuiper belt, from 10,000 astronomical unit to 100,000 astronomical unit, there is another spherically distributed huge collection of such icy planetoids, and quite often it is seen the dynamics is quite difficult from the influence of the gravity due to the motion of our outer planets. Sometimes the Kuiper objects, some of the smaller Kuiper objects, they can launch into the solar system. In the same way, because of the movement of the outer stars that are passing outside the Oort's cloud, the spherical construct that is even beyond the Kuiper belt, there we find that certain such planetoids, they can be thrown into the solar system all on a sudden, and when they come into the solar system, sometimes they move with very high speed. It is normally seen that they move with the speed of, when they are quite far away from the sun, their speed is about, say, 2000 miles per hour, but when they approach the sun, their speed sometimes may even reach up to 100,000 miles per hour. So they can quite appear all on a sudden. And since our monitoring from this small part of the solar system on Earth is only limited, we cannot monitor all the vast amount of space surrounding us, and so it may so happen that sometimes such sudden comets appear. Actually, these objects, when they are thrown into the solar system in a highly elliptical orbit, and when they become repetitive visitors to the solar system, we call them comets. They become comets, and they become spectacular even more when they approach the sun, because of the solar wind coming out of the sun. They form a tail, and in fact, sometimes they form two tails, one distinct part of the gas tail and another distinct part of the dust tail, and they separate out and become an interesting sight. And depending upon the size, the brightnesses may vary. So that's how the comets normally come into the picture. And what you said is interesting. Yes, this comet was not earlier much known, because when these comets are thrown in from the Kuiper belt, normally they form small period comets. I mean, their orbits are smaller and they are quick visitors to the solar system, like the comet Halley. It has got a 75 years period. But when the comets are thrown in from the Oort's cloud, which are much farther away, they have more elliptical orbits, and they normally are very peculiar things. I mean, they are launched into a very long orbit, more than 200 years or so. You probably know that Pluto has got a period of 165 years. So their periods are even longer, and they travel even farther and far away from the solar system sometimes. And not only that, I think you will explain it later on.
We will go into a bit detail of all those structures.
Yes.
Slowly.
Yes.
Actually, as you have just said, that see these comets now, previously, say long back prehistoric times, when people suddenly saw like broom-like structure or something like that, fuzziness in the sky. Now they, in Latin, maybe they have call these words like cometa or something like that. So from that cometa, nowadays actually it has metamorphized into the word comet, modern word comet. Lot of things actually, like in moon we have the Maria, and this Maria were known as seas, and a lot of words were taken from Latin literature, and it has been put into this astronomy. Astronomy is actually the oldest science, and a lot of people, lot of cultures have influenced that. Now, when actually we saw that the first supernova was actually witnessed in 1054. That is our Crab Nebula. They have witnessed the supernova, and during that, around that, as far as the record goes, around 1059, say they sighted the first comet. Don't you feel that during those periods of 1053 or 1050 to 1060, we have some records, so people started actually seeing the sky? How do you feel from historic point of view? Means during that time whether they were more towards the development of the knowledge, or they suddenly had more interest in the sky, or something, because a lot of records show that during these periods they recordically see a supernova, they record it, they see a comet, they record it. They might have seen before that also, but there is no actually written Babylonian or Egyptian concept. So can you do you think any?
No, I think astronomy was an interest at that point of time. Even before that, we find that different cultures they recorded astronomical observations.
But India, I think,
forms.
India there is
No,
no much.
I feel that in India there was an interest as well, and in India the astronomy was very strong. But Indian interest seems to be a little different than what appeared in western part of the world. And my feeling is, while in the western part observation was given more importance, India was more interested into the mathematical analysis of observations.
I think Aryabhatta was the first person to have actually given something about Aryabhatta, and after that
Yes,
he has recorded.
That happened much before such observations. Aryabhatta, Varameda, Bhaskaracharya, all these people, they showed their interest. But India was more into mathematical astronomy than observational astronomy.
Yes.
Observational astronomy perhaps flourished in that part, really. But what I want to say is, around 1000 AD, it is seen that the Islamic astronomers, they play a very important role in identifying several astronomical observations and their analysis as well. They developed observatories, but even before that, the Greeks had astronomical interests, the Mesopotamians and Babylonians, they showed astronomical interests, and there's a reason for that. Historically speaking, the sky is always with you. It is something that you are bound to see. And what caught the fancy of the people perhaps was the fact that if you minutely observe certain items in the sky, you can see a pattern, you can see their movements, and as is, there's a human nature. Whenever we see something, we are pattern seekers. We try to create patterns out of our observations. We try to find out rules, so that this is a very interesting characteristic of human nature, that we always try to predict what will happen in future. So we try to have a forward-looking imagination. Probably this forward-looking imagination gets us into this business of finding out rules, whether we can predict the motion of a certain object.
Halley did exactly that, actually.
Yes.
Previously also there were records of a comet coming and going, but nobody has found out, means nobody has ventured to get that there is a pattern. So Halley, though he didn't discover the comet, we credit him because he has discovered that same after a periodic interval of 74 years, 78 I think, no, it is 74 or 78 years, they actually recur one after the another.
Yes.
And this periodicity throws somewhere, they are periodic, they are something which goes and comes into our sky and something like that. So
He established that they are periodic visitors.
Periodic visitor, yeah. So let us come back. We have been showing some of the pictures which were in the background actually of this comet, our NEOWISE. And NEOWISE actually suddenly it came. We will show you how actually people caught hold of this comet by WISE project. But when it was caught, it became, after it has gone near the sun on June 3rd, and it became more and more brighter. Then people started observing it in the early morning sky. So for example, from July 10th to 15th it was visible on the northeastern part of the sky. In fact, in Calicut also some people phoned me, because our center is in a location where actually the horizon of northeastern horizon is not very clear, because we require because it is low in altitude, no? We require very low altitude clear horizon. We could not get it from here, but some people reported and phoned us also. They from Calicut also, they have observed on one or two occasions, they have observed at around 5:30, 5:15, they have observed this particular comet NEOWISE, and it was really bright. So So then people actually world around, they started, as we have already explained, that see there two tails are ultimately developed. So they saw that there are tails, and they have photographed this particular comet, and you can see that it is really a spectacular comet of this particular year, or maybe a few years from now after Hale-Bopp. This is the comet. We have a lot of other small comets which were coming and which were not very spectacular, but this was really a spectacular comet. And then actually they have also calculated, and they have found out the orbit, and say from July 14th to, we will show you that as the month goes on, the comet raises in the high up, and it comes up in say at an altitude of around 40 degree, and it is near from Lyra. It is going to the Ursa Major, and we should have a good view. But what do you feel about the timing of this comet? I think the comet should have not come now. It should have come sometimes in say January or sometime, because now the time is in the sense that it is locked down, people have time, people are not busy, all those things are fine, but again it is monsoon time. So what do you say something about it? Can you say something about it?
It's an interesting observation, and good, it's true indeed. But there are few issues. Number one, identifying a comet is not always so apparent. There are chances of misidentifying and taking something else as a comet, because even though we see distinct tails, even though in photographs, in most of the cases those photographs are taken by professionals, those photographs are taken with high resolution instruments, and that is why those things are so apparent in the photographs. But when we see with our naked eye, and particularly from environment in which light pollution is a huge problem, and as you mentioned, this time it is monsoon time. You know that we made a few futile attempts to spot and identify this comet during this period. But interestingly, this comet appeared at a time when in the first part from June to first part of the July, it appeared before the sunrise. Somewhere around 2 hours before the sunrise. But the problem was, at that time it was very, very low above the horizon. So to see it, you need a clear horizon without any halo, without any light pollution, and you need to see it with a lot of patience, because and there is another misconception that I'd like to mention here. People sometimes think, we also had this wrong notion maybe somewhere in our childhood, that comets are also like meteors or meteorites. They whiz past through the environment or through the atmosphere, but it is not that. Comets are normally very slow moving, in apparent motion when we see it in the sky, and with respect to the stars it moves very slowly, and they can be seen almost in the same position if we observe it over a day, or rather over a night, that we can see. Anyway, yes, this comet seems to be an interesting visitor because it is bright enough to be observed, but it also seems to be an untimely visitor. It should have come when the Calicut sky was much clearer.
Not only Calicut, in full India actually. In India,
monsoon season. So we can perhaps make a request to the wood cloud and the Kuiper belt that please send your emissaries only when our skies are clear, because we love them and we love to enjoy and see them.
And one more thing, one thing is that previously, maybe before this, I don't know how the scenario is much better here. Previously, people used to think, maybe last century also, people used to think that these comets are harbingers of something, they are something, a symbol of evil or something which will make some difficult times in far ahead. Some superstitious things were available in the common psyche of our society. I think now it has got reduced. Now people are much aware, and science centers and planetariums has played a great role in actually demystifying all these concepts. What do you say about it?
Hopefully we are doing that, but I'm still not very sure. I keep my fingers crossed. And I always very, very strongly put it forth that you can quote me on that. Astronomical events cannot influence the events of your life. Absolutely uncorrelated, absolutely unfounded. There cannot be any influence. Earlier, what happened is culturally, since I told you that we are a pattern-seeking species, we always try to relate things. But in our effort in doing so, we sometimes also relate uncorrelated things. And that is why science is important. Two things, or even some regular recurrences of events may appear to be correlated, but they needs to be properly observed. The data needs to be recorded. Data need to be recorded, and accordingly, it is necessary to analyze them to give an actual pattern of the whole thing. Whether they are really related or not, that needs to be established. I think with the scientific methods and procedures, not only the science centers and planetaria, but also the press, the media, the schools and colleges, and of course the regular curricular institutions, all of them have helped at least to establish that yes, the comets are no harbingers of bad time, and even in other astronomical phenomena, you cannot find out any root of anything that is influencing your common life on Earth, because on Earth we are guided by our interactions with nature, we are guided by our own physiology, our own anatomy, and the science that relates to terrestrial things as such. Yes, of course, we are exposed to radiations, and that can interact with us, and that can have physiological effects, but just by passing some, say, 200 or 1000 astronomical units away, one astronomical object cannot influence our life in any way.
But one thing is quite, see, when I was here, I came to Calicut around 1995 actually. I saw that during that period, 1994-95, we had Comet Hyakutake coming in, and 1996 I think it is, and it was there in the sky, and it was quite bright, and then Hale-Bopp was there, and these two were very bright for our city. And actually initially lot of people came, and lot of people saw this comet. It was quite high, it was nearly, say, around 60 degree of altitude it was, and it was available late night also, and ultimately the full city saw. Then everybody actually saw things, and after that Comets was there, nobody was bothered, and it was for a quite long time it was there in the sky. And this particular comet also, only the thing is that we have a cloudy sky. It is also quite high, say around 40 degrees, quite a good altitude for viewing a comet. And it is the Ursa Major is also quite easily visible from many parts of the city, and actually in our latitude. And so I think it is a very good way of seeing this comet. But I will not fully disappoint. I think it may not fully disappoint us in the sense that though it is rainy season, what I feel is that there are a lot of situations when after a period of shower we get a clear sky, and if it is something like before 23rd or something, if we get a clear sky, I think around after 23rd there is a prediction that it may become, somebody is telling that it may become non-naked eye object. You may require a binocular telescope, but otherwise also, if it is clear sky, we may be able to catch up with this comet.
That is why there is a situation really that when it is going up, it is becoming fainter. So there's a catch point. Whether we will get a clear sky before it loses its brightness. But if yes, it's a point of chance, it's a question of chance. If we are that way lucky, then probably within a few days, if we have a clear sky and it is not fade enough, then we can once again observe it in our city.
And one thing is that I think there is no correlation between the comet in the sky and the cloudiness of that particular area, because that should not be that comet is forbidding us from seeing itself. Those reasons are absolutely wrong. Actually, like eclipses and its cloudiness in the particular area. This is a faraway object, and just with a clear sky we can see it. So those superstitions.
I think in this respect you can just mention what would be the closest approach of this comet to the Earth.
Yeah, that we will be showing it.
Okay.
So this particular comet not only was after it was discovered, and amateurs and professionals and observatories globally started pointing wherever there is a clear sky. They started pointing the object, the telescopes to the sky. And you know that it is quite interesting that our space telescope, the IA International Space Station, they actually has they have captured this particular comet, and it is so good. You can see in this video which they have posted in the net, that as the International Space Station is flying through the darker part of the Earth, so it is moving, and then slowly it is going, and it will be capturing the image. Then you are seeing the background sky is there, and it is moving. This site itself quite aesthetic, you know, because
yes, of course.
Can you say something about this particular site?
Any view from the International Space Station is revealing. To me, there are several points of attraction. Number one, the big span of the Earth doesn't allow us to realize how it carves down. Any sight from the International Space Station actually gives us the three-dimensional geometry of the Earth. We can understand how its surface carves down, how the atmosphere is a thin layer just above it, and our position in this whole space. We are, even though here it appears quite big because it is being observed from a close distance of the Earth, still we can understand how vast this space is and how small we are. That's a very philosophical understanding that always I am led to whenever I look into something that is taken from the International Space Station. And it is also to me a great feat of the human understanding of science and technology that we can place some object permanently at such a position and observe our Earth from a distance which we are not allowed normally from the bindings of the gravity. But when we go out, we can see the countries, the nations, the skies. We can understand exactly how the sun rays fall on us, and
see, India is seen. Can
yes,
you see the Gujarat is seen?
India is seen. The Gulf is very clear over there, and we can see the night light patterns all over the country.
And you can see the day coming. No?
Yes, the day is approaching
day
us,
is coming.
and just before the day strikes us, this gives in fact the reason also why we see this planet just before the sunrise from India. The day will slowly approach towards the part of the Earth where India is, and just in a while the comet will be seen in the sky. And the International Space Station has now gone past the Indian region. It has gone over to China and approaching the Russian region perhaps, and from there, yes, here the tails are visible, and just in a while the whole planet will be visible. It's a spectacular sight. It's brilliant. It's
And
mesmerizing.
best is the thing is that it is not bothered about whether it is monsoon or whether it is any
Yes,
climatic
because
condition. It is above climate.
Yes,
Space
exactly.
telescopes are placed above the atmosphere, so it can see a lot of things.
Yes,
And
that is a very important issue. Most of, I mean, I will not say most, but many of the important astronomical observations are done beyond the atmosphere. It has to be so because atmosphere works as a filter. It filters out quite a large part of the electromagnetic spectrum.
In fact, only two are seen: radio
Yes,
and
the visible light and the radio waves, they are only permitted through the atmosphere to the surface of the earth, and hence any object which are radiating in other parts of the spectrum will not reach us. For them, we need observatories above the atmosphere.
Hubble Space Telescope is a glaring example. We got so much to know by this particular telescope.
Yes, but Hubble actually observes in the visible region and the IR. But we have other observatories like the Chandra X-ray observatory, and there are other observation points, I mean instruments which observes astronomical objects from within other part of the electromagnetic spectrum.
I'll just share one thing, that see, you are seeing a line which is demarcating between the bright part and the dark part. Now this we see in our moon quite, because we not appreciate that, but we see it in phases. We see and this line is called terminator, and you see that how much brightness difference comes when we just are on one side or the other side of the line. So this is quite spectacular. And
this site is also revealing in the sense that it shows why during the daytime the planets cannot be seen.
Yeah.
Not only the planets, the comets, planets, and the stars, they cannot be seen. This difference of brightness shows us why it should be so.
And actually astronomers and other scientists, space scientists, have calculated, and they have done a great job in finding out the true orbit. In fact, nowadays with some calculation and some observations, you can predict the path, and of course the path changes. We will discuss about it. And for this comet, this is the path which is shown here, which you can see that this is the NEOWISE comet path, and it is crossing in a very wide angle. And there are actually a lot of calculations, and people have calculated day-wise where the comet will be, and it can be actually traced from our popular planetarium softwares like Stellarium or Starry Night, and people can actually point at each day. For example, in this particular thing, it has been for July 1st to 31st how the comet's position with respect to the constellation it has been shown, and you can actually, if you know this particular chart quite well, for example on 23rd it will be near this particular Leo, and it will be Dubhe Merak near that Ursa Major. So from the background actually you can know from where is the particular comet. And
just a minute, here I would like to mention one thing. Here's something interesting to observe. That there are comets of different natures. Some comets, as I told you, that some comets they are prograde. They move in the same direction as the planets move, and they are almost close to within 30 degrees of the planetary plane, plane of the planets, and they are almost in the same plane, and they are close to, that is why they are seen close to the ecliptic. These planets are normally small period, I'm mentioning it as planet, but it's comet really. These comets are really small period comets, and we understand that they come from the Kuiper belt. So when they come from the Kuiper belt, since the Kuiper belt is placed in the same plane as the planetary plane, plane of our planets, the ecliptic plane, that is why when they come inside the solar system, they are also in the same plane, or at least close to that plane, and they are prograde, that means they are rotating in the same direction. But when the objects are coming from the Woods cloud, they are coming from any direction, and they are sometimes prograde, sometimes retrograde.
In fact, our Venus is a retrograde planet, and people there are a lot of theories about why should Venus be retrograde and all other planets should move in one direction. So there are theories, lot of theories.
Yes, that is an exception, but what I am trying to say is, from this observation actually, it is established that Woods cloud is a spherically symmetric construct. Because when objects are coming from Woods cloud, there is no particular direction of choice. They come from any direction, and they can be prograde or retrograde. And this object, this comet, in all probability is a Woods cloud object, and hence,
some are we will be discussing it. Some are also saying it as a scattered disk object. Some are classifying it as a scattered disk.
But
So
perhaps the jury is still not out.
It is still debatable because its orbit is changing. Its orbit is changing.
Yes, and that is another point, that it is not a two-body problem that will come subsequently. So it's quite complex than that. But what I wanted to say is this, that when you observe comets and their paths, you can find out that this comet is moving in an eclipse which is much elongated.
Eccentricity is high.
Eccentricity is quite high, and there are smaller eccentricities for other comets. That is what we can see in these curves, what you have shown just now.
In fact, people have actually drawn the path with respect to this comet path with respect to the background sky from actually this year, and it has up till 2021. They have actually traced the full path and calculated it. But after this particular July or maybe start August, the comet will no more be a visible object in the sky. It will fade off very fast as it moves out of the moves across the sky, and we may be have to have the aid of a telescope and better optical devices to actually find out the comet in the sky. So that is a thing. Now we will just introduce that this normally actually amateurs are very much comet finders or comet hunters. You know, our lot of comets like Hyakutake or our this one, which 1994 we have the Shoemaker Levy. They were all discovered by amateurs, and actually it was their cup of tea. But nowadays, since actually a lot of different objects, minor body objects are there, and nearby objects are there, people are actually, this is one of the examples where actually by data analysis of the data captured by a spacecraft, we are getting discovering in fact a comet. So this particular comet, NEOWISE, it is actually named after an acronym for a spacecraft called Near Earth Object Wide Field Infrared Survey Explorer. So actually this is a project which NASA has formed, and it started in 2009. It started with a project called WISE. So WISE is that same thing, Wide Field Infrared Survey Explorer, and it started in 2009, but by 2010 of September or something, its fuel, that is coolant, has gone out, and it has to be stopped operating from 2011 February. But again, since it was capturing lot of data, so people started again reusing it from 2013 onwards, and it is going on, and it has been registered as a Near Earth Object Wide Field Infrared Survey Explorer, or NEOWISE as it is called. And this comet is actually honoring the spacecraft by naming the comet as a NEOWISE. It was the first bright comet. Yeah.
I'd like to mention one thing about the naming of comets. Naming of astronomical objects are controlled by one international authority called International Astronomical Union, and there is a convention of naming the comets. The comets are either named after their discoverers or after a spacecraft that spots the comet for the first time. And in this respect, I would like to mention a recent article written by one of our friends, Dr. Ashwin Shekhar. He is an astronomer, and he has mentioned an interesting observation. I would like to, I'm concerned about it, and that is why I would like to bring it in. It's an interesting story. That in newspapers some stories were coming out that some people were collecting funds because they wanted to name one particular star after the name of Sushant Singh Rajput, who recently very sadly died in a miserable situation, and who had great interest in astronomy and who were associated with astronomical observations in several cases and places. In fact, a very good quality telescope was one of his treasured possessions. So the fans and the friends, when they found that there is some initiative like naming a star after his name, probably somebody deposited some money as well, but our friend Dr. Ashwin Shekhar, he has very categorically and clearly busted this myth that naming of such kinds are not allowed at all. It is only the International Astronomical Union which can name astronomical objects, and they have a policy that never ever any payment would be allowed in naming of any astronomical object. It is only a common honor given to the discoverer or something or some person who is associated with the discovery. That is how it is named. It is not named any time, and by giving some money you cannot actually purchase a name like that, and that is why I wanted to mention. So this comet was named by its discoverer, which in this case is a spacecraft. So it's an acronym, but it's an interesting acronym. Is a meaningful acronym otherwise, but really the name came from a much longer scientific nomenclature of this spacecraft that is covered.
And it is said that this spacecraft, it is actually surveying or observing the near Earth object, that is asteroids or minor bodies and comets and all those. And interestingly, it has got into its data of nearly 1.5 lakh objects, and out of these 34,000 they claim that they are discoveries. They have accounted for new objects which were not there. And this is operated by JPL, and its data processing is done by infrared analysis center at Caltech. So a lot of people are doing a lot of jobs, and this data analysis is a very good job. And we can just see a glimpse of the profile.
This movie shows us a bird's eye view of all the asteroids and comets observed by the NEOWISE project from the start of the survey in January 2010 until mid-September.
So it's showing actually the survey had how much
how the space is scanned and how the new objects are identified and the database is created out of that for future study.
So they are showing that red dots are something which are cometary things which are recently discovered. And then there are blue dots and green dots, and this scanning the sky and getting lot of data, and ultimately making a database out of it, and then analyzing those database to get a new insight about what all objects are. Because if some objects are coming near us and it is actually a danger to the threat to our own planet, we can be much prepared for taking care of that. So
here I would like to mention another thing, that comets are of special interest to scientists for studying the history of the solar system. Because on Earth we have lost the actual signatures of the ancient period, because our environment is a dynamic agent and it is continuously reshaping the Earth. So it's very difficult to find out the early ancient signatures of the original condition of the solar system. But since these are also ancient objects, these comets are also ancient objects, and they are considerably raw in their form and texture. That is why sometimes the scientists perform experiments with them. It is not that we only observe them from a distance and only terrestrially they are observed. They are of course observed the way it has been shown by the spacecrafts. But I would like to mention about another interesting experiment that was done in 2004 and 2005. There was one comet tempo to which one impactor was thrown from one such spacecraft, and that crashed and evaporated the comet altogether. And it collected data, it collected shapes to study the morphology of the comets, and that gave us loads of information and insight what these comets are. One interesting observation is that the comets have a density which lies between 0.1 to 0.25 grams per cc. That means its net average density is much lower than the density of ice. So it cannot be a solid object altogether. It's fluffy. It's a combination, it's porous perhaps, and it's a combination of many things. Yes, ice is an important component, but there are carbon dioxides, there are other gases, all in frozen state, and in fact in them there are pockets of volatiles, and when the impactor did hit the comet, some volatiles bursted out of it. Even normally such volatiles come out of them, and interestingly there are also some metals in them that are found. So studying the spectrum of their trails and studying their components, studying their surface features, whether they have crasts, whether they have craters, crater-like formations, all these are of astronomical interest, and for that astronomers and spacefarers they try to go close to the planet, to the comet as far as possible in many cases, and there are special projects through which these comets are studied in space on their orbit, getting closer to them and sometimes impacting them as well.
Yeah, our deep impact mission was actually
yes, deep impact mission was one such mission.
So interestingly, you see that this picture was a raw data picture from these IR signatures of the comet NEOWISE, that is CE 2020 F3, and they have seen that this red, they have actually color coded it. They have seen that we will have the next slide which shows the animated version. So they have seen that an object is shifting as you take the picture field from day to day. It is shifting, and from this actually this was the first indication that the comet is
it could be a comet.
It could be a comet, and then actually they made the calculations and they published it. They found out the orbital elements, what is the eccentricity and what are the other parameters for this particular comet, and then actually many observatories have also tested it using various observational techniques and filters, and there is something called a blinker, one of the instrument with which actually Pluto was also discovered. So using blinkers actually they have categorized and confirmed that yes, so this is from the Sliding Spring Observatory in Australia, and they have used this particular telescope on March 31st. They have confirmed that it is comet. So it was announced globally that a new comet was discovered, and it is actually going, but nobody was sure that it was not a very promising comet. It was a small 5-kilometer wide comet, and it was moving towards the sun, and as most of the comets go and end up in the sun, because by sun's huge gravity what happens is that the comet breaks and falls into the sun. So people thought that this also would might have ended its life somewhat like that. But then we have the SOHO coming inside, and our comet entered inside the SOHO's field, the coronagraph, where they actually close with a coronagraph. They close the disk of the sun, and then they see the comet, and they, as you can see, that the comet is seen here. And to their thing, that comet survived after passing around the sun, and it has become very bright, and that is something really spectacular. So what do you say something about this? Gives a turning point to this particular comet.
Yes, sir, there lies a mystery really. What you said is correct. You mentioned that it's a 5-kilometer comet. Now, this 5-kilometer actually mentions it refers to the core of it, and the comets are normally from
Various
1
size.
kilometer to say 100 kilometers.
Yeah.
That is normally the size of them. But when they come close to sun, because of the sun's solar radiation, their tails can be much longer than that. So the comet size, when ultimately we see in the sky, is much bigger
It's an
than that.
extended object.
It's an extended object. But whether it can sustain the gravity of the sun or even the gravity of the bigger planets, larger planets like Jupiter, that's an interesting phenomenon. Their motion is not really a two-body problem only, where their motion can be explained only under the gravitational field of the sun, because they are subjected to the gravitational fields of other objects of the solar system as well when they are moving.
And one thing I will just interrupt you, because see, there are few similarities I found. For example, our general theory of relativity had one confirmation test by shifting of the perihelion of Mercury as it moved around the sun.
Right.
So here also, for this particular comet, you see that as the comet was incoming, it has a certain periodicity, because its parameters were of certain type. And when it has outbound, when it has come inbound, it has a periodicity of around say 4,000 something. But when it has come out, it has become more elongated, and its periodicity is its orbit has become more eccentric. So it has curved, and its periodicity is around 6,000 to 6,800 years. So this gives not only the macro scale. I think in micro scale also we see that, for example, the orbital gets shifted as it revolves around. The orbit gets shifted and it revolves around. So much similarities we find, and it's quite interesting to see. Yeah.
It is, because it is a multi-body problem. These things are only apparent to happen. But what I wanted to mention is something else. That yes, comets are small bodies, but even then, since they move in a very elongated and high eccentricity orbit, when they come close to the sun, they are subjected to huge gravitational pull. And this gravitational pull over even the span of 1 kilometer or 5 kilometer have a differential character in nature. So the closer part to the sun experiences a much bigger force than the other opposite part of the comet, and that creates a differential stress in the body itself, which is called tidal stress. And because of this tidal stress, these bodies, they sometimes break apart into smaller parts and smaller pieces.
Vaporize.
Yes, and vaporize even. But the fun is, normally whether that will happen or not will depend upon the original construct of the body, whether it is tough enough to sustain that tidal force. That is also important. And it normally, when such comets come in with a highly elongated orbit, they cannot sustain it. They end up close to the sun. And that was expected or anticipated for this comet as well, but it didn't happen like that.
That is quite strange.
That is quite strange. So that makes it an even interesting point of observation we need to follow up with it to find out what is its own construction, so that it could sustain the perihelion. Even going through the closest point of approach to the sun, it has come out of that part. Now it is approaching Earth. It will be close to Earth very soon, and it is still intact. And since it is intact, it is giving this bright spectacle in the sky. We are lucky enough that it is happening, and some people have already photographed it with its long and segregated tail. But at the same time, it is also a curiosity which I think the astronomers and physicists will follow up in future.
In fact, in some of the literature in astronomical papers and researchers, they have found out that a comet, when it crosses 2-3 times, when they have apprehended 2-3 times around the sun, each time they have heat and which evaporates, and their characteristic, the spectrum also changes and their composition also changes in the process. So they give out more what is inside, and older comet gives more insight of what is inside the comet than actually a newer comet. So those things are also there. So this particular, actually when they were observing this, we have taken this slide because they reported it, and they did the photometry and the morphology, and they said that initially for first 48 hours they didn't see. For example, if you see this picture, for first 48 hours they didn't see much, but then after next day they saw that it becomes 1 degree, it was increasing, and then it becomes around 14 degree, 15 degree.
The tail was increasing.
And then it is 45 degree, and then actually they made a publication that yes, it is the brightest comet, which is one of the things which will be hitting the sky, and it will be really a spectacular thing. And people have published the light curve. Actually, it's a curve with magnitude versus dates, and magnitude gives an indication of what is the brightness. Normally our sky in the stars we see from 1 to 6, that is what Hipparch classified, or we see actually moon, sun and all we see, and with our telescope we see much fainter. The higher the magnitude, the fainter is the object, and lower the magnitude, the brighter is the object. Hipparch classified between 0 and 6 all the stars in the sky, but moon and sun is -13 and -27 in magnitude. And so you can see that this particular magnitude has reached nearly around 0, and on June 7th it has reached 0, so it is very bright. And up till June 21st, which shows this particular graph, you can see that up till this June, then up till around say August, it is a naked eye object, and then it becomes a binocular object. So these types of curves actually what our observatories have calculated and formed.
With it we can find out what is the possibility of spotting it without any aid.
Without any aids, yeah. But it may change. These are all actually theoretical models based on what is observed. But anyway, the comets, it may change also. That is also, it is already dimensioned. That's what people say. So these are actually chronology of events as and when it passed through different dates. You can see that it passed through different constellations like Auriga, it passed through Ursa Major, and it passed through Coma Ventus. It will pass by July 31st. And again in up till here actually we can expect up till July 23rd, when it is closest at a astronomy means 0.6292 or approximately very approximately 0.7. That is, one astronomical unit is Earth-Sun distance, average Earth-Sun distance, and it is around 0.692 astronomical unit, or it is the closest, or that is what we are expecting. And that day, if the sky is clear, I think we can expect a good view. It will be high in altitude, and we can expect quite a good view.
Here, one interesting point is that on July 3rd July, it reached the perihelion, which is the closest approach to the sun, and that was 1/3 the distance of the sun to Earth.
Yeah,
that is 0.29 astronomical unit, which is almost 1/3, almost 1/3, even lesser than that. So it was pretty close to sun, and when it comes close to Earth also, it is almost at the same distance, at least 70% of the distance that the Earth is from the Sun. So that is quite far off.
That is quite coincidental.
That is quite far off. So it shows how fluffy this space itself is.
Yeah, and we can see as we continue this timeline, August, though this will become a binocular object, but even if it is a clear sky and if you have a good pair of binocular or a medium-sized telescope of say 4 inch to 6 inch is good enough, you can spot this for this particular comet. It will be also this magnitude will not drop much, so that it is a binocular or a small telescope object, and still we can see this particular comet, but then you require an aid to do that. So, how to know actually where is the comet? For example, now the comet is in our sky. You know, there is a site. This is the site which shows this particular site which shows that where is the comet. So it rises in Calicut sky at 6 o'clock. It transits the mid sky at 12:55 and 12:54, and that was yesterday's data. And actually, I have taken, before I started this presentation, I took this today's data, and today's data it shows somewhat like this. If you take it here, today it has yesterday it was at 6 o'clock. Today it has come up the horizon at 6:15, and up till 8:05 today we are expecting. So this is quite good time, and I hope that if the sky is good enough, sometimes in evening at least, during these days, we can actually see this bright comets.
We'll make further attempts from our science center, and if we can do that, since in lockdown we cannot invite you to our place, but if we can do that, we'll try to capture, or we will try to show you live through our online channel. But let us see, for that we have to get a clearer sky. We'll wait till then.
Yes. And now let us again revisit whatever we have been describing so far, that what is the journey of the comet. We will now go into a bit detail about from where the comet comes, where it goes, how it changes its life, what is the life cycle of a comet. So we will go into detail, but let us start from the point that comet has started the orbit. Let us think about from where it came a bit later. Let us think from where it started, as it takes a closed path. Most of the comet, now people actually they are less prone to thinking that it takes a parabolic open orbit path. People used to think, but now they think that these are actually long period comet, but ultimately it is a bounded orbit. That is, it is a closed orbit. So as you can see, that orbit, it is a mass with a certain size, and as it comes near the sun, it goes around the sun, and as it goes, due to the intense heat of sun, its thing vaporizes. You can, as you have already said.
I have already
just you can say the
mentioned all that.
Viewers,
that when it is far off from the sun, the tail is not visible, because in that case, at that time, it is only the core that is remaining. But as it comes close, the coma forms first.
And when it is nearer to our sun, the coma means tail is the, because that time the heat is very high. So
not only heat, but also the solar wind.
Solar wind, yeah. And tail is always pointing opposite to the direction of the sun.
Because there is a pressure of the solar wind, and that blows it away. The solar wind is the flow of plasma, the stream of plasma and particles that come out of the sun and going away from the sun. So they will push up, and they will throw away the tail on the other side. So that's how it is formed, and as it comes close, there would be a distinct difference of the dust tail and the plasma tail and the gas tail. And once again, after the perihelion, when it crosses, then the tail gets smaller and smaller, and slowly it will get back to the core once again. But in each turn, it will lose some of its material, and hence the comets come with an expiry date, with a finite life of it. So probably will not live long to see whether these comets will end up after how many cycles. But there are classical estimations, and there are mathematical modeling which suggest that each one of them have definite cycles to their life.
Yeah. And now let us, as we have been describing again and again, but let us look at the comet a bit closer. So what we have been saying is that the comet is after all a dirty in the sense that dust, and water vapor and organic compounds like methane, ethane, and say hydrogen cyanide. So it consists of lot of material. Sometimes some elements of metallic elements are also present. So studying this, actually we know that how the comets get originated, whether it has originated from our solar system. So this is one of, I think, one of the scientific aspect of studying the spectra of a comet. Origin of the comet gives origin, reflects something about origin
History of the
solar system. And then we can also find out this how, with what pressure actually the solar wind is getting bombarded, and how long is the tail. And you can see the tail is around 1 to 10 kilometers. So it is a very big, quite a
the nucleus.
Yeah, nucleus is 1 to 10 kilometers, and the tail is around 33. Yes, I was wrong. 33 million kilometers. That's quite a big thing. And so such a small object like our NEOWISE is around 5 kilometers. This is some other planet, this is some other comet, and it is around 10 kilometers in nucleus. And this is the anatomy. So if you have a more detailed structure, you can see. And one thing actually you can see that the tail, the iron tail and the dust tail, they are not aligned. So
yes, they will be separately interacted by the
and I think charged particle of this solar wind and the ionic tail, because they are also charged, that will have certain things, because dust is normally an uncharged type of particle. Actually, they are microscopic particles, ice crystals, dust and ice crystals, maybe carbon particles with some ice crystals. So their density and the density of the ionic tail are different. So they are both gravitationally bound to the nucleus, and but since dynamically they are different, I think they take separate path in the space.
But yes, I have not studied their dynamics in a lot of detail, but yes, apparently it appears so, and probably there are much more detail into it, but I am not immediately aware of it.
Yeah. So there is there are a lot of things to get from studying the comet as such. So now since we have seen the anatomy of a comet, let us go into actually the source from where the comet comes. And there are a lot of theories, lot of things, but things are actually getting consolidated, and people are trying to understand and getting some insight. Actually, it all started in 1951 when actually Jan Hoot, he theorized based on a lot of observations and all, and periodicity of lot of comet. He said that there is a big spherical cloud from around 50,000 to say 1 lakh to 2 lakh around in that astronomical unit range, which is surrounding the our solar system, and that he called as the Oort cloud. But then people started thinking that Oort cloud is not the only, because there are a lot of short period comets which were discovered, and there the total say major axis which of the
but still
orbit,
if you can show geometrical,
we will be showing that. So basically actually they divided it into something called as scattered disk object. That is the near, that is actually that is near the planet Uranus, not Uranus, the Neptune's region, but it is not affected. And then we have the Kuiper belt, which is from 30 to 50 astronomical unit, and beyond that we say that it goes
to a spelling mistake. Actually it is written as KUIP.
KUI, okay. Kuiper's KUIP, yes, you're correct. So it is a typographic mistake. So we have 3 sources actually, and now for this NEOWISE actually people are categorizing it as a scattered disk object as of now. It may change, and then on the scattered disk object there are different types of new comet names, like they are telling that some comets are having influence of Jupiter, so there are Jupiter forms. So Jupiter family comet, JFC they call Jupiter family comet, and there are long period comet like Halley type comet. So these two are actually referred in scientific literature. We will be seeing that, and we will be speaking about certain things within Oort cloud and all. As we go on we will be speaking. So this Kuiper belt is somewhat like this. It is beyond the is post Neptune. Actually, Neptune in most of the time, some of the time actually it was the, now actually it is the last planet, but previously when Pluto was also considered as a part of our solar system, we had sometimes Neptune going out and sometimes Pluto coming in, and there was confusion, but now it is the outermost planet. So beyond Neptune we have a belt like our asteroid belt between Mars and Jupiter. This is a belt of numerous objects.
And this image also shows why we call Pluto a Kuiper belt object.
Yeah, because it is in this particular range. And then we have, then people have told you, this is the consolidated picture. You can see that we have the solar system here, and that is a part of a bigger, you can see the asteroid belt and solar system, and then we have seen how is the solar system compared to the orbit of the Sedna, which was also discovered, and you can see the Sedna here, and you can see the Oort cloud. So this slide actually shows the dimension aspect, how big is the thing compared to our solar system or other objects. So this also gives an indication of about sun and how far the sunlight goes, the heliophase, heliopause actually, and then beyond that we have the stellar interstellar space, and you can see that Oort cloud is lying from 10 to the power T to 10 to the power 5. So this is the full, it's a spherical cloud which Jan Oort has actually initially thought about, and it contains a lot of cometary materials, from which what he thought is that there are a few stars like binary stars or certain massive things which passes nearby, and as a result of which actually a part of this chunk of this object gets unstabilized in its region, and it forms a gravitational tour, and it comes to the inner solar system, and then we are able to view it. So that is what actually people thought about it, and so this gives a broader picture. But then there were a lot of problems that this model was actually challenged, and there actually we had people like J.G. Hills. He said that no, it is not that, it is not uniformly distributed. There is a toroidal space inside, so there is something like a inner Oort cloud and an outer Oort cloud. Inner Oort cloud where you see some of the because all the comets which come actually they don't account for the density as it is conceived of the such a big spherical cloud. So what feeds the comet there? So based on that actually he theorized, and we have also another thing about inner structure of the Oort cloud by the origin of heli-type comet, from long distance comet, from where they came. It has been done by Lewison, Dones and Duncan, and he has actually they have actually dwelled on this type of heli-type comet, and they also theorized about this particular toroidal shape, and then they also have scattered disk and scattered disk object, and how actually they are combined to give a better insight. So this is a consolidated picture, as you can see. So it is not only a spherical cloud, a spherical type of thing surrounding our cometary base. We also have a central disk, that is which we see in the center, and that is actually the trans-Neptunian type of object. That is also,
and they have a connection, the Kuiper belt and the Oort cloud
Kuiper
are
belt
connected.
and scattered object, scattered disk object, and the Oort cloud. But all this Kuiper belt is somewhat very much within. It is around say 50 astronomical unit. But then you have the Oort cloud, which is very vast. You can see, for example, this is just an artistic view, and this is showing how the bubbles are inside and how the connections are made. But this is a more actually measured, means it is calibrated in the sense that you can see that it is our Oort cloud is from say 100,000 astronomical unit, and it is some of the paper says that it is around 200,000 also. It is a vast space, and actually the density of comet in this outer Oort cloud, outer shell of the Oort cloud is not so much as it is in the inner shell, that is the Hills cloud that it was called. So this model, our perception of this comet as a science, actually this gives how the comets are formed, whether they have been formed from our solar system or whether they have been captured from outer things, and whether they go on capturing. So they throw a lot of science. So studying of comet is very important from this aspect. What do you say about
Yes,
that?
of course. It gives us not only the material history of the solar system, but it also talks about the dynamics of the solar system, how it was formed, how it is evolving, and that is why I think knowing our immediate ambience is important. It can also decide some way what the future would be. And anyway, we always try to understand what the future will be like. So,
And one more thing is that, see, this comet's orbit, once it has been destabilized from either of these, like hyperbelt or scattered disk object, or as a scattered disk or wood cloud, it comes in a path, and then there are a few perturbers, like we have Saturn
Yes.
and Jupiter. Jupiter
Yes.
is the major perturber, and of course Sun. Sun, it will of course rotate and go, but its path of Jupiter alters the path very frequently. So it's very difficult to say in precisely actually what is the orbital parameter. Will it be constant in future also, because it can change. So that is one aspect that should be taken into consideration while speaking about these comets. So before we actually conclude this session, let us give a small thing about, see, normally we have this two body, the Kepler, Johannes Kepler has formulated 3 laws of planetary motion. Not only it is applicable not only to planets, it's applicable in general to orbits, central orbit problems, that especially the second one, that square of the time period is proportional to means third one, the square of the time period is proportional to cube of the semi-major axis, or equal areas are swept in equal interval of time. This is an angular momentum conservation thing. So based on that, actually two body problem. So this comet and sun, they form two body. So it is not a problem of two body, it is a multi-body problem, because as you know that Jupiter and other objects may also be there, and it's a comet, like 5-kilometer comet passes near an asteroid of bigger size, they can deflect the orbit, so there can be perturbers. So that is in a macro scale, it is really a complicated many body problem, but we can idealize it as a two body problem, and this particular equation is the equation of two body, whose solution is given by r is equal to c by 1 plus epsilon cos phi. So that is actually somewhere like a conic section formula. So all objects, all these planetary objects, they move in various orbits which are a part of conic section, but nowadays people say that they are part of the closed orbit problem. So we can calculate the minimum distance from the sun, maximum distance from the sun. So based on all this, yesterday we were sitting and discussing, and we've found out that actually we took the parameters of this orbit from eccentricity of our comet NEOWISE, and we found out that the maximum distance, as far as now, present thing, it is 745 astronomical unit. So there is actually
close to 1000
yeah.
astronomical
So
units.
there is actually some comment that what should be classified. Some visitor has asked what should be actually whether we should classify it as a Oort cloud object or whether it's a Kuiper belt object. As far as present understanding, it is beyond actually 50 astronomical unit. So it goes towards indication that it is a as far as this data is concerned, it is a Oort cloud object. But anyway, that is debatable. A lot of people have not yet, and there are perturbers also. It is in a return journey.
Since it is a dynamic situation, we have to study what it was initially, because as of now what we are seeing, it has already been subjected to several gravitational field perturbations.
That we don't know. Past history is not known to us.
Exact past
Yeah.
history is not known, and that is why probably much more data analysis would be required. But apparently, yes, it shows that it will head towards the Oort cloud.
Unless Jupiter or somebody or some
Once
other
again
minor
deflects
planet
it quite
deflects its
significantly.
path. It's a small object after all. It's a 5-kilometer object, and so summarizing, these are all it can have different types of icon. It can be circular or elliptical or parabolic or hyperbolic, or based on actually what are the orbital parameters, and this actually in most whether eccentricity, how close it is passing the sun, or with what velocity is coming, what is the energy. So the second, for example, this is the energy equation, shows the relation between eccentricity and energy and the lattice rectum and all those things. So these all things actually determine in large the dynamics of a comet as well, because it is a thing which determines dynamics of any objects under the central force, like gravitational force is the central force, but in comet also it is applicable. So now I think as a conclusion, what do you like to say? That I think now our viewers have got some insight about why the study of the comet is important, what is to be known about our NEOWISE comet, and it is a rare opportunity, and we should actually all be keen and actually perseverant to see whether it is observed in the sky, and we should take care and actually see this comet if possible, because next comet, whether it will be so bright enough, we are not yet sure. So when it will be, when we will get a chance, what do you say?
Yes, so with all these details we understand that we are not yet done with this comet. Just seeing it is not enough, studying it is more important, and as Eddington said, that it is not only important to appreciate the beauty of the stars, but it is also very interesting to understand how it works. So if we are interested to go further detail into it, we will find that beyond its visual spectacle, there are far more beauties in its dynamics, in its science, and that is really the core inspiration of doing science, to finding out how things work. So I'd invite one and all to follow it up, to look for the scientific works that are published around not only comets, any such natural phenomenon, because that makes us understand our world in a much better way.
So I think thank you for joining us, and we thank all the viewers to have actually been with us for
thank you very much. And finally I'd like to say that yes, you know, in this pandemic situation we cannot open our science center, but one thing is very clear, that whatever happens to us, it is only science which can give us the way forward, which can find out solutions for the problems that we face in life. So keep on renewing your connections with science, and we are looking forward to the time when beyond this pandemic, once again we can see you in person in our science center. We will come out with many such stories.
Thank you very much.